Hello, welcome to Sisyphus Crane and Rigging. We are building a trapdoor. Not a trapdoor, more like an elevator door. Except it's not really for an elevator. Elevator doors are vertical, but they do slide apart. They oppose each other. I guess it's a set of miniature sliding doors. I'm actually not sure what to call this thing. I'm Mr. Bix. Welcome to my channel. I'm doing a kinetic art project. Rather ambitious. It is bound to get involved eventually. So, I'm playing with these miniature ball carriages with precision rail, and you can't help feeling the smooth action and wondering what you can build with it. They're loaded with ball bearings and a recirculating track, so the balls are captured in mating sets of grooves, both on the rail and on the carriage itself. Makes for a low friction linear motion while holding extremely precise alignment. When an idea like this comes to me, my mind, my thoughts tend to race through all the bits that go into it in order to flesh it out. Parts that aren't quite clear in my mind they drive me to open up the computer and get on CAD and see if it can't be worked out. One thing leads to another. I'm in SolidWorks, and before long I'm making drawings of the parts to be machined. By the way, I looked up sliding doors. You know what? There seems to be no name for them. I mean, things like this have a name, sort of. Like that little door on your car that opens up to put the gas in? That's called a fuel filler flap, which is a lovely name. I remember the sliding doors in the opening montage for the old TV show Get Smart. My dad would never let us watch Get Smart or anything like that, the Three Stooges and stuff. He always said, it's stupid and stupidity isn't funny. Maybe stupidity isn't funny, but I always thought Get Smart was a hoot, probably because of all the gadgets. So anyway, I'm off to the machine shop, need to make a bunch of parts. I started with making the main holding block and then the pinion shaft and its holding block. There I was reaming it out. Putting flats on the shaft. I had it in the lathe and I turned it down. I had a miter gear on the end of the motor, but I abandoned that. Needed a more rigid bracket and it kept climbing on the gear, so that's fixable, but I decided just to go ahead with a straight coupling. Milled out the racks, put slots so that I can adjust them to get the doors adjusted properly. I wrote a little program to mill a profile around the doors, knowing that I'd be able to save that when I go to do them in aluminum. Here I'm just using 1/8 inch plastic mirror that I had scrap laying around. Go around a couple of times, get a nice smooth finish on them. Now I'm cutting out a piece to make the make the riser. So I'm doing a setup to screw it down to a piece of, it's actually a piece of laminated shelving. The stuff is very flat and it makes a pretty good setup block, although I'm committing the big sin of machining wood in the mill or the lathe. People don't like to do either one. But for a quick and dirty one-off, it worked all right. First you drill a hole pattern into the block below. Then you clamp down your work and you drill through holes through the work. Then drop screws down into the whole mess and lock it together, which will leave it ready to do the profile mills for the outside and the inside cuts. On the other parts, I quickly realized that I'm going to save some time if I just chuck up a blade for this. It's a 3/32 inch Allen head driver, and I used a drill to put those in. Much more efficient. That's the outer profile with a 1/2 inch end mill. Then I grabbed a single flute plastic end mill to do the inside. Followed it with the vacuum. It took several passes, but I only show one. The single flutes work really well. They don't heat up as much Leave a really nice finish. You can get them from places like Harvey Tool. And there's the finished part. And I gotta put in the taps. 4 places. Seems like I'm fiddling with these parallel bar clamps forever. The parallel bar clamps are really handy for setups. You can get them on eBay. They're always available. Try to get the good ones, Starrett and Brown & Sharp and that sort of thing. I've got a number of them and I use them all the time, all sizes. So I'm touching off on the part and getting a 0. I come in and pre-drill, and then I ended up power tapping them. I had to move that one in because it was wobbling a little bit. I used alcohol, that's just straight methanol sprayed right on there. It evaporates nicely, doesn't leave a mess. It keeps the tool cooler, provides a little bit of lube. Pretty handy stuff. There's the power tapping. Put it in low gear, drive it right down, hand on the brake, shut it off, stop it before it finishes out, and then you don't ruin your taps. Then I had to put the whole block back in to drill the side holes because that was a change. Putting holes on the inside of this thing instead of on top saved 4 holes exposed, 4 screw tops on the top of the plate. And I just drilled those out for a 440 clearance, 116 thousandths inch drill bit. So I screwed that thing together and then grabbed the doors and put them back on. Actually used flat heads where the door is attached instead of those socket head cap screws. And those 4 positions right there required button heads because the carriages actually interfered. I changed those out later. And there are the doors going back on. 256 screws are what I used on that. And there it is assembled. So when I had the assembly ready before I put that riser part on, I set it up on the bench and used a little train transformer with a switchable direction on DC to drive it back and forth. This is the first test of the sliding door system. The doors are in the open position. I have it rigged up now for the first time with limit switches and diodes. Closed, open, closed. There's the circuit that it uses. And there are the limit switches. Right there. The diode is back there. Back to the build, I needed to make the top plate through which the doors are seen, and so I screwed down a piece of 1/8 inch aluminum onto the masonite again, and again I just drove the screws down right into the wood, okay for a one-time job. This is where I got the drill to make the job a little quicker. And I put that down and milled out the outside. Then this is just a chamfer operation that I'm doing right here. Went around that a few times. And then I got ready to do the center hole. Used a 3/16 end mill for that. I'm just using a 2-flute carbide end mill. Went around that whole thing. I'm spraying on that alcohol again for a little bit of lubrication. And I actually chamfered the inside of the hole too for appearance sake. And that's basically it. Just milled down the plate. It'll get finished up later. There's the chamfer operation. I took it off and there it is. This is the original one I made for the original Kineticon. It's made of sheet metal. You can see how it opens and closes by a lever, little lever arm, made of that same sheet metal, K&S brass sheet metal. And that's how I signed the machine. So that my name would pop up out of there every time the machine ran. Actually ran twice. And this was made back at the end of the 80s. So that's, no, sorry, the end of the 70s. And you can see how I made a little lever, spring-loaded, slipping clutch mechanism. Worked out pretty good. And that thing ran for probably close to 1 million times, because the original Kineticon ran for, I made over $100,000 on it. That's 400,000 quarters. And it ran 2 to 3 times per cycle. So it's way up there. The original Kineticon was finished at the beginning of 1979, and it went into the Mill Creek Mall in Erie, Pennsylvania. And then after we moved to Utah, I put it into the Newgate Mall for a while in Ogden and various other places. I even went back to Erie for a spell. But it wound up in Trolley Square for the majority of its life, and it finished out in front of the old spaghetti factory there. A great location, but all told, I ran the thing for over 15 years, and at an average of something around, I forget, $8,000 a year. That's how I ended up making, over $100,000 on the thing. But eventually it wore itself out, past the point at which I had the willpower to recondition it again, which it had been through several times. But everything was worn out, and I felt, it's time for a new one. So back when I made those top parts, you can see how they look when they're on, and you can see the look that I'm going for. Now this will mount down on the table, and it'll open during the cycle, during the run of the machine, and something will pop out. I'm not sure what. Stay tuned for that. There's an interesting effect that's going on here with those temporary doors that I made. They look like they're totally misaligned. I'm going to tweak them to get them better aligned, but you can see there's no bump there. They're actually fairly well aligned as it is. The reason why it looks that way is because when they make those, it's 1/8 of an inch thick, and they put the mirror surface on one side. And when I loaded them into the mill, I didn't pay much attention to which sides they were. So one got made upside down, and the mirror surface is on the bottom of the plastic, and the other one's the other way. So they look misaligned. I'm going to be cleaning up the top there. I'll do some kind of a flat sand or something to make that look good, and then get them anodized. And that's the idea. That's the trapdoor. And that's the end of this video. Stay tuned for more. I've got a lot of things to do for this project, including something coming out of that trapdoor. Not sure what yet. And this is Mr. Bix. Is it not absolutely original?